Hi everyone. We made it to the end. I'm super excited to go over my presentation about my project and kind of teach you about maple syrup urine disease. I actually, some of you might have read in my discussion post that I work in the NICU, and I actually saw a baby who had this disorder. So I was super interested when I saw it on the list to choose from. I was like, oh, I want to do more research. And I found some really interesting things that I hope you guys can enjoy. So, to begin, a description of this disorder is maple syrup urine disease is a rare genetic disorder which is caused by a deficiency in an enzyme complex called branched chain alpha keto acid dehydrogenase. I know it's a mouthful, but basically, um, there is deficiency in this complex, which this complex is important for breaking down key amino acids. And so these amino acids build up in the body and produce toxins, and their byproduct is very harmful for humans. So that's kind of like a brief description. I'll go more into the cause of it in the next couple slides. First, some symptoms and characteristics of this disease. I might say disease or disorder. It's the same thing. So normally symptoms appear 24 to 48 hours after birth, and the condition gets its name from its distinctive sweet odor from the infant's urine. And in the case of the baby in my unit, her urine was very sweet smelling and actually had this characteristic. So after they did this initial screen, they found out that she had this disorder. Symptoms may include neurological dysfunction, lethargic, irritability, poor feeding, vomiting, and, as previously stated, a sweet smelling urine. And this might seem like not a big thing, but if this is not treated, seizures can occur, death, and even, comas. And so if it's not treated and caught right away, it can be serious, very serious. So maple syrup urine disease it's pretty rare. It affects an estimated 1 in 185,000 infants worldwide. So that's really not too common. However, in the old Amish population, their numbers are significantly higher, with rates between, from 1 in 380 newborns. And, from this class and just, doing genetic research, that the Amish community is very tight knit, and so genes can get passed on more frequently. So, there's a higher chance of this disorder being inherited. So the cause is basically caused by 3 possible mutations in these 3 genes: BCKDH, BCKDHB, and DPT genes. And as previously stated, there's a deficiency in a complex, and these genes provide instructions for making proteins that work in that complex. So hopefully that makes sense. And this complex is needed to break down 3 key amino acids: valine, leucine, and isoleucine. And so when there's mutations in those genes, the complex can't properly break down those 3 amino acids. So, and these mutations can reduce or eliminate the proper function of the complex. So the byproducts of leucine, isoleucine, and valine, they all build up because those genes can't properly work in that complex. Hopefully that makes sense. I tried to, I know it can be confusing, but hopefully that makes sense. So basically, the complex isn't working properly and can't break down those amino acids. The mode of inheritance, so this disorder is an autosomal recessive pattern, and as we've learned in class, that means so in order to be affected, the infant has to have 2 copies of the recessive gene. So in this picture, so it says the dad is a carrier and the mom is a carrier. So since they only have 1 copy, they don't show any symptoms, they're not affected. But one of their children, if they get 2 recessive genes, they will be affected by it. So it's rare, and there is a 25% chance that child won't even be a carrier, 50% chance that the children or child will be a carrier, and then a 25% chance that they will be affected. And this is just a little pedigree showing, what happens, let's say, when the dad is actually affected and the mom is not affected. So as you can see, because you have a little r, big R, it makes all of their kids carriers. So none of them are actually affected, none of their children are affected, but if one of their kids were to marry someone who is affected with a little r, their kids have a much higher chance of being affected as well. Um, but that's just kind of a pedigree was for one of our projects, and it just shows that if you are a carrier and you marry someone who's also a carrier affected, there is a higher chance of passing the genes on to your offspring. So with the genetic testing, as we learned in class, newborn screening test is mandatory in all states. So initially, babies will, when they're born, they'll go through the newborn screen, and this is kind of just a generic screen that looks at a bunch of different genetic disorders and possible screenings. And so if the newborn screen comes back positive for maple syrup urine disease, then they can also do a specific panel which analyzes 5 genes that associated with the disorder. So they can narrow down what mutation they actually have. And from further research, they cannot detect this from maternal blood. So they can't do a genetic test while the mom is pregnant. It has to be once the baby is born. And typically, the testing is done 12 to 24 hours right after the baby is born. 12 to 48, kind of. The sooner the better for sure with this disorder. And there are many different therapy options, and it's super important that there are interventions right away. First off, they must remain on a protein-restricted diet that limits the amount of leucine, isoleucine, and valine, because, as I previously stated, if they have this mutation, their bodies are not able to break these down. And so if you keep having it in your diet, it will build up and it will produce toxic byproducts that's actually very harmful for your brain neurologically and growth and development. So you do not want to have a diet that contains large amounts of those 3 amino acids. And there's actually special formula options, so babies get the proper nutrients that they need to grow and develop without having, the high amounts of those 3 amino acids. And this will start right after the baby's confirmed positive and has gone through the genetic testing. And even after, they've been diagnosed, they've been on this, special formula, special food and diet, they still need to be regulatorily monitored to make sure that their diet is meeting their requirements and that their levels are staying normal or average. So in some of my research, I looked at future therapy options, besides just a diet, and they have actually done liver transplants to treat individuals with MDSU. And interestingly enough, once they get the transplant, individuals are symptom free and able to eat normal foods without any dietary restrictions. But obviously, the availability of livers is low, and it costs a lot of money, and there's more research that needs to be explored to see, the positives and negative effects of a liver transplant. Lastly, the infant outcome, as I've kind of tried to emphasize, early detection is crucial along with lifetime treatment and monitoring. It's super important. And, if the proper steps are taken, individuals can live a happy, healthy life with normal growth and development. But, even with all this, some people might still experience flare-ups. And if it's not treated correctly, that toxic byproduct can build up. And unfortunately, infants can pass away, or adults, from it. So it's a very rare disorder, but, I hope you guys learned something about it that you guys can take away. And thank you for listening. Oh, these are my references. Thank you.